Hey everyone, and welcome to Study Primer. Do you think trigonometry is just this huge, messy pile of things you have to memorize? Well, today we're going to blow that myth right out of the water. We're going to focus on one single, perfectly symmetrical angle that honestly unlocks everything, the 45-degree angle.
You know the feeling, right? It's the classic student nightmare, staring at these endless trig tables, making flashcards, just trying to cram it all into your brain. But what if I told you there's a much better, way more elegant way to do this? Let's just dive in and I'll prove to you that with a little bit of logic, you can figure all of this out, everything from scratch.
And here it is, the star of our show today, the 45-degree angle. Now, this isn't just any angle. It's special. And why is it so special? It all comes down to its perfect symmetry. And it's that symmetry that makes it the master key. The thing that lets you truly understand trigonometry instead of just, cramming for a test.
Okay, so to see where all this magic really comes from, we got to start with our most important tool. We're going to build a very specific triangle from the ground up, and we're going to build it on the perfect foundation for the job, the unit circle.
So what exactly is the unit circle? It's actually super simple. It's just a circle, right there at the center of our graph, but it has one absolutely crucial feature. Its radius is exactly 1. Not 1.1, not 0.9, just 1. And that one little number, it's going to make everything so much easier for us.
All right, let's build this thing. We start by drawing a line from the center of the circle, and we split that first quadrant perfectly in half. That gives us our 45-degree angle. Now, since that line is the radius, we already know its length is 1, and hey, that's our hypotenuse. To finish it off, we just drop a straight line down to the x-axis, and voila, we have a perfect right-angle triangle.
Okay, so we've got our triangle. We know for sure the hypotenuse is 1, but that brings us to the real million-dollar question. How long are the other two sides? This is the point where we stop drawing and we start using pure logic to find the one key number that solves this whole puzzle.
So, to find the length of those two missing sides, we're going to bring in an old friend, a tool I'm sure you've seen before, the Pythagorean Theorem. This is what's going to help us nail down our key number.
Now, remember that perfect symmetry I mentioned? Because our angle is 45 degrees, those two shorter sides are exactly equal. So let's just call them x. Now we can plug them into Pythagoras. A squared plus b squared equals c squared. For us, that's just x squared plus x squared equals 1 squared. That simplifies to 2x squared equals 1. We solve for x, and what do we get? We get that x equals 1 over the square root of 2.
We are so close, but there's one little thing. For reasons of, well, let's just call it mathematical style, people don't really like leaving square roots in the bottom part of a fraction. It's kind of like an unwritten rule. But don't worry, there's a really simple trick to fix this. It's called rationalization.
And the process is super straightforward. We take our fraction, 1 over the square root of 2, and we multiply it by the square root of 2 over itself, which, if you think about it, is just a fancy way of multiplying by the number 1. When we multiply across the top, we get the square root of 2. On the bottom, the square root of 2 times itself just becomes 2, and that gives us our nice, clean final answer. And there it is, the square root of 2 over 2. This is our number. This is the key that unlocks absolutely everything else. It's the length of both of our triangle's shorter sides. And now that we have this one number, you're about to see that calculating all 6 trig functions is basically child's play.
So here it is, our fully solved triangle. Just take a look. The hypotenuse is 1, the side opposite the angle is the square root of 2 over 2, and the side adjacent to the angle is also the square root of 2 over 2. We officially have everything we need.
All right, now for the fun part, the big payoff. Since we know all the side lengths, calculating all 6 trigonometric functions becomes unbelievably simple. So, let's start with sine. Sine is just the opposite side divided by the hypotenuse. Well, that's our key number, the square root of 2 over 2, divided by 1, which is of course just the square root of 2 over 2. Easy. Now, what about cosine? That's the adjacent side over the hypotenuse. But wait a minute, since the opposite and adjacent sides are the same length, the result is exactly the same. This is so important. For a 45-degree angle, sine and cosine are identical twins. And the tangent, it gets even easier. Tangent is just the opposite side divided by the adjacent side. Well, since both of those sides are the square root of 2 over 2, we're literally just dividing a number by itself. And what happens when you divide any number by itself? You get 1. How clean and simple is that?
So we've already knocked out the 3 main functions. Now what about the other 3? Cosecant, secant, and cotangent. I know, the names sound a little intimidating, but don't let them fool you. They're just the reciprocals, the inverses, of the ones we just found. All we have to do is just flip the fractions over. That's it.
Okay, so cosecant is the flip of sine, and secant is the flip of cosine. So if we take our key number, the square root of 2 over 2, and we flip it upside down, what do we get? We get 2 over the square root of 2. And uh-oh, look at that. We've got that pesky little square root in the denominator again. Looks like we have to rationalize one more time.
No problem, we already know how to do this. We multiply by the square root of 2 over itself. That gives us 2 times the square root of 2 on top, and just a plain 2 on the bottom. Now look, the 2's on the top and bottom just cancel each other out, leaving us with a beautifully simple answer, the square root of 2.
And just like that, the puzzle is complete. I mean, look at how perfectly this all fits together. Sine and cosine are both the square root of 2 over 2. Their inverses, cosecant and secant, are both the square root of 2. Tangent is 1, and its inverse, cotangent, which is just one flipped over, is also 1. It's all just perfectly symmetrical. And the best part, we didn't have to memorize a single thing.
So as we wrap this up, I really want to focus on the big idea here. Because this whole exercise, it's about way more than just finding some values for one little angle. Here's the real takeaway, the moral of the story. We memorized absolutely nothing. Zero. What we did was we built a shape, we applied a theorem we already knew, Pythagoras, and we deduced one single number. That's it. From that one number, everything else just flowed out of pure logic. And that is the core idea I want you to walk away with. Understanding the process is always, always more powerful than just memorizing the answer.
And that really leads to one last question for you to think about. We just took apart a tiny piece of math to see how it works on the inside. If we can do that with a simple angle, what else in your life are you learning by just memorizing it when you could be truly discovering it for yourself?
And that's it. That's how you can figure out every single trig function for 45 degrees without an ounce of memorization. If this logical approach helped you out, do us a favor and give this explainer a like. And be sure to subscribe to Study Primer for more lessons that are all about understanding, not just memorizing. Share it with a friend who's stuck on trig, and we'll see you in the next one.